All right, so now we're going to talk about experimental design. Experimental design is all about how we're going to go about collecting our data. We've identified the population that we want to measure something on, and we've decided what question we want to answer so we know what we're going to measure on them. Now we've got to develop a pretty good plan for collecting that data, right? And this is one of the most important things that you're going to do in statistics when it comes to trying to collect your data if you ever have to come up with your own experiment, survey, whatever, observational study, whatever. How you go about doing it is supremely important to make sure that the data that you're getting is good, and you can make some different, some very good inferences from that, some good conclusions from there. Okay, and some of the key characteristics that you have to think about with experimental design is control, randomization, and replication. Okay, and the reason why is because you will inevitably run into some possible confounding variables. What a confounding variable is a variable separate from what you're trying to measure on a population or on a set of subjects. Or on a sample. It's a variable that is separate from what you want to measure, but could possibly be driving your results, right? So if you can't tell the difference, when you get your results, if you can't tell if the results are because of what you are looking for to measure versus something outside of that, then that variable has become confounded. And so here's an example. An owner of a candy shop remodels her store to make it look better, right? Obviously, to try to bring in more customers. But at the same time that she remodels or finishes the remodel, the mall next door has a grand opening, okay? Turns out she ends up selling more candy on that day after she finishes her remodel and the mall has a grand opening, right? So now the question becomes, if she sells more candy, right, is it because of the remodel and the store looks nicer, or is it because the mall next door had a grand opening and there's a ton of people there already and they're just trickling over to buy more candy than what they would have otherwise, right? So now the effects of the remodel and the shopping mall having its grand opening have become confounded. Obviously, as the business owner, what you wanted to find out is if the remodel was causing you to sell more candy. So the shopping mall opening becomes your confounded variable, and you can't tell. That's going to happen all the time, right? And even as you're trying things in your own life, right? You can't sleep. And you've been sleeping fine, now you're not sleeping so well, and a couple of things have changed in your life. Some of you guys at some point will get a night guard for your teeth if you haven't already. You've turned the temperature down in the house, right? So when you stop wearing a night guard and you raise the temperature in the house and now you're sleeping better, you don't know which reason it is for the better sleep. So those have become confounded and you want to try to figure out which one's driving your results, right? So we got to watch out for that. You also have to, especially if you're performing an experiment that involves a treatment, which experiments will, you have to be careful of the placebo effect. And I know we've looked at this already, but a placebo is if you're going to give a treatment, if you're going to perform an experiment, then you almost always need to have a control group that receives a non-treatment but looks exactly like the treatment. That's called a placebo, right? A placebo is a non-treatment, but looks just like the actual treatment. So now you can tell, you can try to tease out this placebo effect. And the placebo effect occurs when a subject acts favorably, right, to a placebo when in fact they've been given no treatment at all, right? In other words, if I want to test a headache medicine, I'm going to have one group take the headache medicine and another group take a placebo, so looks just like the same pill, but has no medicine in it at all. And then I'm going to see, right? And if a subject that is that has been given a non-treatment, a placebo, comes back and says, "Hey, my headaches are gone. I'm cured. Thank you so much. This works so well." That becomes the placebo effect, and it happens a lot. The mind is a powerful thing. And the mind can help you overcome a lot of different things, or can cause a lot of different issues just in and of itself. So we have to tease out the placebo effect a little bit in how we set up our experiments, right? One way to do that is by blinding. Okay, blinding in an experiment means that that the subjects don't know if they're getting a treatment or if they're getting a placebo, right? You can either blind an experiment or you can double blind it. So blinding is if just the subjects don't know if they're getting a treatment or not. The people performing the experiment do know, or I guess better said, the people observing the results or measuring the results do know, but the subjects do not. A double-blind experiment is when the subjects nor those that are measuring your results know which treatment has been given, right? No one involved in the experiment itself can know who's getting the treatment and who's not in a double-blind experiment. The people measuring the results and the subjects find out after the experiment is done. And again, that's just to tease out as many confounding variables as we possibly can, right? In the case of the headache medicine, we don't want the doctors that might be measuring those results in any way affecting the results by suggesting to those that are getting a treatment to also do something else to help their headaches versus the ones that are not getting a treatment, right? So if no one knows who's getting the treatment, then your results are going to be a little bit more accurate and reliable, right? So sometimes you can just single blind and just make sure the subjects don't know who's getting the treatment or their placebo, but a lot of times you're going to want to double blind so that no one in the experiment except the person that is setting up the experiment, of course. Someone has to know, but those that are in this, the subjects and the people measuring the results don't know who's getting the treatment, okay? And here's a pretty good video on the possible effects of the placebo effect. Sorry, let's try that again.
The idea was to treat people in great pain. Volunteers with severe knee arthritis were gathered from around the state and divided into groups. 2 groups would have a surgical procedure. The third would be given a placebo, fake surgery. They'd have a general anesthetic, be opened up, but wouldn't have any real procedure. They would merely think they had. I had to meet the surgeon.
It's very important for the patients not to know which treatment that they have. And they're always trying to look for clues. You know, they're always trying to get you to tell them. And the best way to avoid that, of course, is to not know as a doctor until the last minute which treatment they're going to have.
Each patient would receive a general anesthetic, but only 2 groups would have an actual procedure. Not even the surgical staff knew who was in each group until they were in the theatre.
I would open the envelope in the room and I would read it, but I wouldn't announce it out loud. And then I would show it to the nurses who were working with me, and I would show it to the anesthesiologist, and nobody would ever say which of the 3 treatments was revealed in the envelope. We had a very elaborate ruse, if you will. I would play a videotape on the TV of a real surgery. And while I was watching the TV, I would ask for instruments and pass things back and forth and carry on conversation. as if it was what I would really have done if what was happening on the TV screen was actually going on during that surgery. So we would have water splashing, we would have instruments clanking, and we would do this for the same amount of time that the actual surgery on the videotape took place, so that a patient and their family couldn't watch the clock and say, oh, we were only in the operating room for 10 minutes, so it must have been a pretend surgery.
All this acting felt a bit weird to a doctor trained in standard surgical procedures.
In the big picture, always in the back of my mind, I was thinking, good gosh, here's a patient who we're pretending to do surgery on. We're not really doing surgery, and I'm a physician and a healer after all, and is this kind of really, the right thing to do? Or what have I gotten myself into?
It took 2 years for the study to be completed. Finally, it was time for Dr. Moseley to hear the truth from the patients themselves.
I would say, if you think that the surgery helped your knee, I want you to give me a thumbs up. If you think the surgery didn't help your knee, I want you to give me a thumbs down. And if you're not sure or you're kind of neutral, just hold your hand flat. Twist your knee.
The verdict? Success for every group, fake or genuine. Sham surgery had worked. The patients who had it were astonished.
The response ranged from, you got to be kidding me, I can't believe it, bewilderment, there must be a mistake, because they all felt so strongly that something had happened to change what was going on inside their knee.
During your training, what were you taught about the placebo effect?
Nothing. I had no clue. I went from being a skeptic to a believer. I realized that we were really onto something. There are clearly cases where we do surgeries and it's as much or more the patient's feeling about the surgery that influences the result as the actual surgery itself.
Dr. Moseley had seen patients get better purely because of what was in their minds. The pain had gone. It seemed too good to be true, and it did all happen 7 years ago. I wanted to see one of the patients who'd been in great pain before having Dr. Moseley's surgery. I wanted to know whether the placebo effect could still hold.
When I first had that pain, before that, I couldn't do a lot of things I did, like going fishing or playing basketball or going dancing. And after that, I was able to do that.
He could. Woo. We could go dancing. He took me dancing, and he could dance all night.
Can you describe what the pain was like before the operation?
Terrible, awful. I didn't think that it could be any worse.
It's emotional. Why is it because you were in so much pain before?
Yes.
And what would you say it was that really cured you? Was it Dr. Moseley, or was it you and your mind?
That is kind of a intriguing question, because I got to credit Dr. Moseley for doing what he did. But it was my mind that cured the problem.
I knew that Dr. Moseley's patients had been cured by the sham operation, but I wasn't expecting it to have changed his life. I mean, he couldn't talk about the pain that he'd experienced without crying.
All right. So there you go. The placebo effect is real and really, really interesting. All right. So you have to blind to knock out the placebo effects, or try to anyway. And to help tease out confounding variables, you need to make sure that you're randomly assigning subjects to a treatment group. Okay, so randomization becomes hugely important. You don't want to run the risk of assigning everybody with one particular characteristic to the treatment group, not knowing if that characteristic is what's helping or if the actual treatment is. So you want to completely randomize. And there's a couple of different ways to do that in an experiment situation. Observational studies. There are other ways to choose your sample, and we'll talk about that a little bit later on. But with an experiment, there's really two ways to do this. Number one, you can just completely randomize, right? So you can take all of your subjects, like these 10, and just start pulling names out of a hat, right? And say, you get the treatment, you get a placebo. You get a treatment, you get a placebo. Treatment, placebo, treatment, placebo. And just randomly pick their names out of a hat, okay? Or you can do what's called matched pair. And so if you're really worried about even completely randomizing, running the risk of having one group share a characteristic, what you can do is you can match your subjects up due to that characteristic, right? So maybe you put the princesses together, and then the superheroes together, and then the villains together, and then the dead people or ghosts together, right? So in other words, you're going to pair everybody up. You're going to pair all your subject up based on a particular characteristic that you're afraid will become a confounding variable. And then you'll randomly assign one of them to a treatment and the other one to the placebo, right? So within the two, I'm just going to pick a number between 1 and 2, and you get the treatment and you get the placebo. That way you know that your treatment group is going to be mixed up and not have that one particular characteristic, and your placebo group is going to be the same. It'll be mixed up and not have share that one particular characteristic, okay? So that's how we're going to randomize to try to tease out those confounding variables. And then the last thing here is something called replication. And replication means a couple of different things. First of all, replication means that we're going to use the exact same process to repeat a study using the exact same methods, but we're going to use different subjects and different experimenters. And the reason why you're going to do that is because it gives you a larger sample space. It gives you more subjects to look at. And with that, you're going to be able to tease out those confounding variables and be able to come up with some more reliable results and some more accurate data. So you're basically going to perform the same experiment over and over and over again, right? So, for example, a new energy drink is being tested on children. Randomly select 10 kids and test the energy drink to see if it does indeed give them more energy. So one idea of replication is that you do this multiple times, right? One, because it does give you a larger sample size, but you're just making sure that the process works, right? So the bottom line is, if you test the results on 10 or 100 subjects, your results will be even more accurate if you increase that number to, say, 1,000, right? The more subjects you have, the easier it's going to be able to tell if your treatment's working or not, okay? We also want to make sure that, if we can't expand our sample size due to a reason, but we can repeat the experiment several times, then every study should try to give us the same results, right? And if it does, then we can be a whole lot more sure about our results and about our generalizations and our inferences that we're going to make, right? So that's the idea of replication, which also means that when you hear the results of one particular study on the news, which happens all the time, that you don't just automatically assume that those results are the truth and exactly what's going on, and you should change your whole existence based around what that one study shows. It's what multiple studies show that lends a whole lot more credibility to those results. That's the other idea of replication. Okay, so those are the things that we're going to try to, and there you go, definitely going to give more energy to those kiddos. That's the idea behind setting up your experiment, right? Try to do whatever you can to get out those confounding variables, whether it's through a control group to help fight the placebo effect, or if it's randomization to make sure that you're randomly assigning people to a group, not just trying to handpick where you run the risk of creating a group that has the same characteristic. And there's a couple of different ways to randomize, whether it's just picking names out of a hat or matching subjects up and choosing them that way. And then also the idea of replication, repeating the process several times so that your sample size can get larger and you can get better results, better idea of whether your results are good or not. Okay?